Hi folks, happy Wednesday. Our target today is to be able to draw force vector diagrams and describe all forces that are being applied to objects. Let's quick take a minute and just talk about some of the forces that we've learned about so far this week, and a couple of them that we're not going to talk about a whole lot in any great detail. First of all, there are applied forces. An applied force is simply a push or a pull. It's a force that we apply on something, or something else applies on something. Like a car is applying a force on the road in order for the road to push the car forward. There are applied forces. There are gravitational forces. Okay? So we know that gravity causes things to fall down. Even if I set a book in midair, if I let go of that book is going to fall because gravity is exerting a gravitational force on the book, causing the book to fall. Okay. There's also the normal force, right? So when the book hits the ground, it doesn't just keep moving through the ground, it stops moving. So why does it stop moving? Because the ground exerts a normal force that is equal and opposite to the force imposed on the book by gravity. The last type of main force that we haven't talked about in any detail, and frankly we won't be talking about it in a super amount of great detail, is the frictional force. There are two different types of frictional force. There's static friction, friction that causes an object to stay in place. For example, I can apply a force on this lamp, but the lamp isn't going to necessarily move even if I'm applying a force to it. Or if you have a really big desk, you could push on that desk, but if you don't push hard enough, you can still apply a force on it, you can still push on it, but it won't necessarily move. That's because this static force is holding the desk in place. And there's also a kinetic force. So we know that kinetic means motion. If there's a car driving down a road, the kinetic force is what's going to eventually bring it to a stop, right? If you just have a car drive down the road, or if you're on a bicycle and you're biking down a street, perfectly flat road, eventually that bicycle is going to come to a stop because of something known as kinetic friction. What we're going to be learning about today is we're going to be learning about how to draw all these different forces in diagrams, and in what situations we need to have all of these forces drawn. In what situations do we only have one or two forces that are actually happening in our particular diagrams? We're going to look at two different examples. We're going to start with a fairly simple one first, and that is just a car driving down a perfectly straight road. Okay, so here's our perfectly straight road. Here's our car. Nice. There's our person driving the car. Nice little steering wheel. A couple other windows. Good. Lovely little car. So what forces are happening to this car? One thing that I will tell you is the car is accelerating forward. I'll tell you that right now. But go ahead, pause the video, and see if you can figure out which of these forces are being applied to the car. Pause the video, try and figure out which ones are being applied to the car, and then we'll go over it to see if you're right. Okay, now that you've had an opportunity to kind of think, let's go over this problem and see if you're right. So first things first, there absolutely is an applied force being done to this car. That applied force is causing our car to move forward. The car is pushing on the ground, and the ground pushes the car forward. Okay. But there's also friction that's affecting our car. That's causing it to slow down. We do know that the car is accelerating forward. What that means is that the force applied is greater than the frictional force. That's why the car is able to accelerate, because the force being applied to move it forward is greater than the force being applied that slows it down. Okay, so there's a frictional force that's a little bit smaller than the applied force. Are there any other forces that are acting on this car? Absolutely. There's a gravitational force. And there is also a normal force. There we go. And these two arrows are going to be roughly the same length and size because the car isn't accelerating downward and the car isn't accelerating upward. So in the vertical direction, that means that our gravitational force and our normal force are canceling each other out. Let's look at one more example problem. So I want you guys to imagine there is an elevator. And up at the top of the elevator, somebody has just cut the elevator shaft chain that is holding the elevator up. And so we have this sort of elevator shaft, and there is this elevator car that is very quickly falling down to the ground. Fortunately, nobody's in the car, so we don't have to worry about that. But we do have to worry about what forces are being applied to this car as it accelerates towards the ground. Okay, so go ahead, pause the video, see if you can figure out which of these forces are acting on our elevator car. Good luck. When you're ready, you can start up the video. All right, let's go over this problem to see if you got it right. Crazily enough, there's really only one kind of 1.5 forces that are actually acting on our elevator. So there is a gravitational force, right? This elevator is on a planet, and planets produce gravity because they're really big, and it's a sizable enough amount of gravity to actually pull the elevator car down a significant amount. And that's why it kind of accelerates towards the ground, is because gravity is pulling it towards the ground. But there really isn't an applied force on it. The chain got snapped. It's not being pulled up by the chain at all. There's a tiny amount of frictional force, like super small, and that's because of air resistance. But that's it. And this is such a small amount of friction, it's virtually negligible, except at very high speeds. So, that's it. Not too bad. I will be posting a bunch of different practice problems on our website for today and tomorrow. I'll also post a couple of just review problems tomorrow for Thursday, just to kind of help you guys prepare for our quiz on Friday. I'll talk to you more when I see you. I also have a kind of Google Hangout / Zoom invite that I'll send out to you guys. Feel free to hop on anytime between 2 and 3, and we can go over any problems that you have with drawing force vector diagrams and with the review for Friday. Good luck. Talk to you later. Bye.